Okay, we're going to be solving linear quadratic systems and eventually go into nonlinear systems. So there's basically three scenarios with a quadratic linear. So if you think about how many times can a line intersect a parabola, max number of times is twice. So there's two solutions and real solutions because these coordinates are real numbers, okay? Or we can have one real solution. That means that the line is tangent. Or no real solutions, but that means that we have complex solutions. All right. So solving algebraically, we're going to do that first. And if I have y is equal to x squared minus 2x plus 1, and I want to solve that system with the line y equals x plus 1, we're going to use substitution. So these are ready for substitution because we have y equals for both. So if y equal to x squared plus 1 and y is also equal to x plus 1, then that means that I can replace either y with the other equation. So if I have y is equal to x squared minus 2x plus 1 and y is equal to x plus 1, then I can plug that x plus 1 over here. Or the other way around, doesn't matter. But now that you see this, should be on autopilot, and your gut instinct should tell you, well, I have a quadratic because this x squared right here, so I really should get everything on the same side. So that means we're going to have to move the x and the 1 over. So I'm going to subtract the x, subtract the 1 from both sides. X's cancel, 1's cancel. I combine these two like terms, the negative 2x and the negative x, and the 1 and the negative 1. And that with 0 is equal to x squared minus 3x. And we have to solve that by factoring. And you use a GCF to factor that one, and the GCF is x. So we have x times the quantity x minus 3. Put the x and the x minus 3 equal to 0, and we get x is 0 or 3. Now you're not done, because when they're saying to solve a system algebraically, that means they want the intersection points. That means we're missing the y coordinates. So how do I get the y coordinates? Well, I plug the x's back into either equation. It doesn't really matter, but normally you want to choose life and choose the equation that is simpler. So I'm going to choose life and choose the second one. So I go over here and I am going to plug in 0 in for x for y equals x plus 1, and 0 plus 1 gives me 1. And I'm going to plug in 3 in the same equation. 3 plus 1 is 4. And don't forget to write them as coordinates. Okay, that's my pet peeve when students don't write it, the final solution or solutions, as a coordinate, and I will take off for that. So our solutions are 0, 1, and 3, 4. And if you want to check your answers to make sure you're right, remember that this is x, this is y. And let me change colors. And this is x and this is y. And if I plug in 0 for x and 1 for y in both equations, the left side should equal the right side. Same thing for 3 and 4. If I plug in 3 for x in both equations and 4 and y for both equations, that means it should be a solution to both. That means the left side should equal the right side, which means that 3, 4 is a point on both curves. Okay, and same thing with 0, 1. Now, if I were to solve this graphically, I'm not going to spend too much time, but we should be able to graph x squared minus 2x plus 1 and the line y equals x plus 1. And when you graph them, you should come up with the exact same two intersection points, 0, 1, 3, 4.